It's 22. All right. Shh. Okay, this lesson's pretty short. It's not that long. Okay, so in terms of kites, so it is a quadrilateral. As we learned yesterday, quadrilateral is a four-sided shape. So a kite is a quadrilateral with two pairs of adjacent sides congruent, and no pairs of opposite sides are congruent. Exactly one diagonal is perpendicular to the bisector of the other. So here you have a kite, two pairs of congruent sides. So this is congruent to this is congruent to this. The angles, one thing it didn't mention is the angles, it only has one pair of congruent angles. This angle right here, ABC, is congruent to ADC. But unfortunately, these angles right here are not incongruent. Another thing it doesn't mention is that the perpendicular bisector actually cuts those segments in half. So it cuts these in half, but it doesn't cut this angles in half. So you have to be very, very careful. And then you do have a perpendicular bisector between the small angle and the big angle. So that is a kite. So AC is perpendicular to BD, and then so on and so forth. The other thing it does know is the fact that this right here, BE is congruent to ED. It cuts segment BD perfectly in half because it is a perpendicular bisector. So that is a kite. The other figure is called a trapezoid. So a trapezoid, it is a quadrilateral with exactly one pair of parallel sides. The length of the mid segment is the average lengths of the two bases. A trapezoid with congruent legs is an isosceles trapezoid that has congruent base angles and congruent diagonals. So meaning this right here is a isosceles trapezoid. So that means the base angles, which is angle R and angle U, are congruent. Since it is isosceles, the segment in between RT and SU, these are also congruent. So you can give those little two tick marks. The diagonals are congruent. The base angles, so these two, but also these angles, so the ones on top, they're congruent also. Now, it does have a pair of parallel sides. So in this case, ST, it's always the base sides of the trapezoid. Those are congruent. So mid segment. So remember, mid segment is when the diagram gets cut perfectly in half, and you know this gets cut perfectly in half because SA is congruent to AR and TB is congruent to BU. If that's the case, if SU is congruent to TR, then the sum of the base, so ST and RU, is equal to AB, but half of it. So it's one half of the sum of the base sides. Does anyone have any questions? So you got to know the definitions of, but be careful though. This is only true for isosceles trapezoid. So for example, if you have something like this is still a trapezoid, but it's not an isosceles trapezoid. So be careful. Okay. So for number one, find the missing length of AC in kites ABCD. So we want AC. This length right here. Opposite sides are congruent. That's congruent to this. This is congruent to this. So that means it gets cut perfectly in half in this direction. So this is the perpendicular bisector. So BD is a perpendicular bisector to AC. Now, if that's the case, AE is congruent to EC. So that means if EC is 20, AE is also 20. And AC is the sum of AE plus EC, which makes AC 40. That is the answer for number 1. Give you guys a minute to write it down. Does anyone have any questions? All right, moving on. Number 2, find the missing length of CD. So in this case, CD is this length right here. Now we know that opposite sides are congruent, or in this case, all sides are congruent. So this is actually, I would consider this to be a rhombus instead of a kite, but it follows the same thing. In this case, BD is perpendicular to AC. Now, this is very important because what happens when we have perpendicular lines? Very good, right angle. So what kind of shape is EDC? What kind of shape is that? What kind of triangle? What's the proportions of right triangles? Does anyone remember? What is the This is a right triangle. So if I want to figure out what AC is, oh sorry, what DC is, and can someone tell me what is the proper name for DC? And what do you get when it's the long one, Adam? And how do you know it's the hypotenuse?
Across from the A.
Yes, it's across from the right angle. So DC, DCE. So this is the hypotenuse. I forgot how to spell it, so I'm gonna write hype. So hype. If you want to look it up online. So I'm gonna put the variable x for DC. So how would I set up my equation for the Pythagorean theorem? Suraj. Okay, good. Oops. Okay, so what happens? How would it look like when I plug my stuff in? Does it matter where I put the 33 and 56? Which is the only one that does matter? The hypotenuse, that is correct. So it doesn't matter whether you write 56 squared plus 33 squared. The only one that does matter is the fact that C is always the hypotenuse no matter what. Okay, so with the calculator, let's see. Okay, so let's see. 33 squared. I cannot do that on the top of my head. So 33 squared is 1,089. 56 squared is 3,136. Add those together, you get 4,225. To solve for x, I had to take the square root. X is equal to, is it 65? Okay. It is indeed 65. So that means x is 65. So that means DC is 65. So that is indeed the answer. All right, does anyone have any questions for number 2? Okay, number 3, we're halfway there. Find the measure of angles of the number angles in the picture. So I need to figure out what angle 1 is, what angle 2 is. So this is a kite, right? So kite, opposite sides. We note that this segment here is a perpendicular bisector to this segment. So that means there is a 90-degree angle. So in this case, angle 1 is the easiest. It is just 93. Now, when I have a perpendicular bisector to this angle, what's happening to this angle? Okay, very good. If the other half is 36, what do you think the other half is going to be? 36 degrees. I have a 90-degree angle on the other side, right? Because isn't angle 1 to this angle a linear pair? And if this is 90, what does this one have to be? Very good. Now, can I solve for angle 2? How would I set up the equation, Nora? I want the equation. I don't want the process. What's the equation gonna look like? You're not wrong. It's right. But I want the equation. All right, Siraj. And angle 2, you're missing the missing angle. Yeah. All right, so 180 is equal to 126. Subtract 126. So 180 minus 126 gives me 54 degrees, and that is angle 2. Because remember, what's the sum of the angles of a triangle, no matter what kind of the triangle looks like? 180. So it's another thing you kind of gotta know. All right, let's do number 4. Same thing, find the measure of the numbered angle. So in this case, it's similar to the one that we did before. Angle 1, 90 degrees. This angle gets cut perfectly in half. So that means it's 25 degrees. Angle 1 with the angle next to it, adjacent, is 90 degrees because it's a linear pair. This is a triangle. And even though it is specifically a right triangle, I can just find angle 2 because the sum of 90 plus 25 plus angle 2 is 180. 90 plus 25 is 115. When you subtract 115 from both sides, you should get 65. Does anyone have any questions? We're almost done. All right, number 5 are the good problems. So number 5, find the lengths of the segments with variable expressions. You ask questions. Okay, all right, set up the equation for me. Before we get to that part, I want the relationship. Yeah, but I want the equation before we substitute.
Oh. So, yeah.
So this is a trapezoid, the mid segment. This is the mid segment no matter what, because the segments opposite get cut in half. AE cuts EB in half, DC gets cut perfectly in half. So that means the relationship is always the same. EF is equal to half of the sum of AD plus BC. Huh? Yeah, now you can, yeah. What's AD though? Yep. Very good. You're substituting. Okay, what do you get when you combine like terms? Very good. 2x is 3x. -5, -6 is -11. You combine like terms. Now there's two ways you can solve this problem. I personally don't like fractions. I know for a fact if I distribute 1/2 to the 3, I'll get fractions. So instead, what I'm gonna do, which you don't necessarily have to do, I'm gonna get rid of the 1/2 by multiplying both the left and right equation by 2. The 2 on the left on the right hand side will cancel because anytime you're multiplying by a fraction, you can actually cancel that fraction out by multiplying the denominator. So that 1/2 gets crossed out. So now I'm left with 2x equals 3x minus 11 after multiplying by 2. Now, telling you don't have to. I recommend it because it just makes it so much easier. Subtract 3x to both sides. -1x minus 11. Divide by -1. X equals +11. Does anyone have any questions? Any questions? Is everyone good? Is everyone good? Okay, now this one specifically asking for the segment. So you gotta plug it in. AD is x minus 5. We know x is 11, so 11 minus 5 is 6. So AD is 6. EF is x. X is 11. BC is 2x minus 6. So 2 times 11 minus 6. So 2 times 11 is 22 minus 6. 16? Yes, no, maybe so. Probably. Yeah, okay. And that is my answer. Does anyone have any questions? Okay, now here's the thing. You don't necessarily have to multiply it by 2. So for whatever reason, if you distribute the 1/2, you can. So if let's say for whatever reason you didn't. So I'm gonna put it right over here. X, you don't have to write this down if you don't want to. X equals 1/2 3x minus 11. If you actually do distribution, which you can, so you'll get x equals 3/2 x minus 11 halves. Do not write it as a decimal because they'll just make things uglier. So just keep it as a fraction. So we're just solving for x. So that means I'm going to subtract 3/2 x to both sides. So x minus 3/2 x equals a -11/2. When you're adding fractions, you have to have common denominators. So for that x, I actually have to multiply it by 2. So 2x minus 3x is -1/2 x. To get rid of the negative 1/2, or you can write it as negative x divided by 2 minus 11 divided by 2. To get rid of the 2, I have to multiply it by 2 to both sides. Negative x equals negative 11, because for the right-hand side, the 2's cancel. And look at that. When I divide by negative 1, I still get positive 11. But why would you want to do that if you can just multiply everything by 2 and it looks nice and looks beautiful like that? So don't do it this way. You'll most likely do something wrong because it's a lot harder to do, and there's just a bunch of extra steps you kind of have to do. But you can though. You can. Would not recommend it though. All right. Last problem. Did everyone get it right? Did everyone get number 5? All right, number 6 is our last problem. All right, number 6 is the hardest problem on here. Find the measures of the numbered angles in the kite. What's the relationship between angle 1 and angle 2? Told you guys in the beginning. Yes, Liam. So they're the same, right? So that means I can just write this x, and then for this one, I can also write it x instead of just angle 1, angle 2, since they're both the same, they're both x. Now, from yesterday, can someone tell me how would I be able to figure out what the sum for this figure would be? From yesterday, does anyone know how? Yes, Liam.
But for square,
This is not a square, by the way.
oh, wait, sorry. I meant for something that has 4 sides.
Yes, very good. That's good.
The sum of all the angles.
Okay, how would I get 360 though?
360 equals 32 plus 90 plus x plus y.
Okay, so yeah, so there's two things you could have done. One, for any four-sided shape, it is always going to be 360 degrees. Doesn't matter what kind of shape it is, it's always 360 for a four-sided figure. Now, if you don't remember how to get that, a kite is an irregular polygon, meaning all the sides are not, all the angles are not the same. So that means I can do 180 and minus 2 to find out the sum of an irregular polygon. If for whatever reason you don't remember that it is a 360, you can just use the formula from yesterday. So 184, right, because it's a four-sided shape, is 360 degrees. So kite is an irregular polygon. It's not a regular polygon. So that means 32 degrees plus x plus x plus 90 is 360 degrees. So it's kind of the same thing like a triangle. Triangle, no matter what kind of, whether it's regular or irregular, is always 360. But for a four-sided shape, it's also the same. For irregular or regular, it's 360. For triangles, it's 180. So we can just combine like terms. 2x plus 122. Subtract 122. 2x is equal to, what is that? Minus 122. 238, is that what you guys got? Divide that by 2. X is equal to 119. So that's what x is equal to for this kite. Does anyone have any questions?